A universe teeming with stars, written by Brian Cox. The universe is vast, it's bigger than we can truly comprehend. Hundreds of billions of galaxies sprawl across the cosmos. Each galaxy is home to billions, even trillions of stars. Many of these stars have planets orbiting them. Some of these planets might be similar to Earth. They might have the right conditions for life. The sheer scale of the universe suggests that life elsewhere is possible. It might even be probable. But here's a curious thought. If the universe is so vast and teeming with potential for life, where is everyone? Why haven't we encountered any signs of extraterrestrial civilizations? This is the crux of the Fermi Paradox. The Fermi Paradox highlights a puzzling contradiction. The universe seems ripe for life, yet we see no evidence of it beyond Earth. This paradox is named after physicist Enrico Fermi. He famously posed the question, where is everybody? Fermi reasoned that even if only a tiny fraction of stars harbor intelligent life, the universe is old enough for them to have spread far and wide. They could have colonized the galaxy by now, so why haven't we encountered them? The Fermi Paradox has fueled countless theories and speculations. Some suggest that Earth might be unique in its ability to support complex life. Others propose that civilizations might destroy themselves before reaching interstellar travel. Let's explore some of these possibilities. One possible answer to the Fermi Paradox is that we are alone. Perhaps life, especially intelligent life, is incredibly rare. Earth might be an anomaly, a cosmic fluke. It possesses a unique combination of factors that allowed life to flourish. These factors include our planet's distance from the sun, the presence of liquid water, and a protective atmosphere. Maybe such a confluence of events is incredibly improbable. Maybe it happened only once in the entire observable universe. However, this answer, while possible, seems statistically unlikely given the vastness of the universe. It implies that we are incredibly special, a notion that many scientists find hard to accept. The sheer scale of the universe presents another challenge. When we look up at the night sky, we see a vast expanse filled with countless stars, each one potentially hosting its own system of planets. The distances between these stars are immense, almost beyond human comprehension. The nearest star to our solar system, Proxima Centauri, is over 4 light-years away. Even traveling at the speed of light, the fastest speed possible, according to our current understanding of physics, it would take years to reach our closest stellar neighbors. For instance, a journey to Proxima Centauri would take over 4 years at light speed. Imagine trying to communicate across such vast distances. The time it takes for a message to travel from one star system to another can be staggering. A message sent from Earth today wouldn't reach a civilization 100 light-years away for a century, and if they replied immediately, their response wouldn't return to us for another 100 years. By then, would they even be listening? Would they still exist? The civilizations we hope to contact might have risen and fallen in the time it takes for our messages to reach them. This communication lag makes interstellar dialogue incredibly difficult. It's like trying to hold a conversation with someone on the other side of the world with a delay of several hours between each sentence. The challenge is not just the distance, but the time it takes for information to travel. This delay can make meaningful exchanges almost impossible. Perhaps civilizations rise and fall without ever knowing others exist. The universe is a dynamic place, with stars and planets constantly being born and dying. Perhaps the universe is abuzz with signals we haven't detected yet. Our technology is still in its infancy, and there may be countless messages out there, waiting for us to discover them. As we continue to advance our technology and understanding of the cosmos, we may one day bridge these vast distances and finally make contact with other intelligent beings. The zoo hypothesis. Are we being watched? Some theories propose that we are not alone, but that extraterrestrial civilizations are deliberately avoiding contact. This is the central idea behind the zoo hypothesis. Imagine a galactic civilization aware of Earth. They might be observing us from afar, studying our development without interfering. They could be waiting for us to reach a certain level of technological or social maturity before initiating contact. This idea, while intriguing, raises ethical questions. Do advanced civilizations have the right to keep us in the dark, like exhibits in a cosmic zoo? Or are they protecting us from something, shielding us from dangers we don't yet understand? The Great Filter. A cosmic hurdle? Another chilling possibility is the Great Filter hypothesis. This theory suggests that all civilizations encounter a barrier that prevents them from reaching a certain level of advancement or spreading beyond their home planet. This filter could be anything: a technological hurdle, a self-destructive tendency, or even a natural disaster on a cosmic scale. It might be an obstacle that all civilizations, including ours, must overcome to survive. The unsettling implication is that we might not have passed the Great Filter yet. Perhaps it lies ahead, a looming threat to our future. Or perhaps we are the first to overcome it, a beacon of hope in a silent universe. Hidden in plain sight, the limits of our perception. Our search for extraterrestrial life is limited by our current technology and understanding. We are searching for signs of life as we know it, based on our own experiences on Earth. But what if alien life is radically different? What if it exists in forms we can't even comprehend, using technologies beyond our imagination? We might be surrounded by signs of their presence without even recognizing them. Our instruments are designed to detect specific signatures like radio waves or chemical compounds. But what if alien civilizations communicate using methods we haven't discovered yet? Our search might be akin to searching for a needle in a haystack while wearing a blindfold. Beyond our comprehension, alien life as we don't know it. The universe is vast and mysterious, filled with countless planets and stars, each with the potential to harbor life forms beyond our wildest imaginations. Our imagination often limits our understanding of what alien life might be like. We tend to think within the confines of what we know, projecting our earthly experiences onto the unknown. We tend to anthropomorphize, picturing extraterrestrials as humanoid figures with advanced technology. This is a natural tendency, as we are most familiar with our own form and capabilities. But the reality could be far stranger. Alien life might not resemble anything we have ever seen or imagined. It could be so different that it challenges our very definitions of life. Life on other planets could have evolved under vastly different conditions. These environments might include extreme temperatures, high radiation levels, or completely different atmospheric compositions. It might be based on different elements, utilizing different energy sources. For instance, life forms could thrive on methane instead of oxygen, or use silicon instead of carbon as their building blocks. It might exist in forms we consider impossible, defying our understanding of biology and physics. Imagine creatures that can survive in the vacuum of space, or organisms that communicate through electromagnetic waves. Perhaps we haven't encountered alien life because it's not where we're looking, or because we wouldn't even recognize it if we found it. Our current methods and technologies might be insufficient to detect these exotic life forms. Our search for extraterrestrial intelligence might require a paradigm shift in our thinking, a willingness to embrace the truly alien. We must open our minds to possibilities that go beyond our current scientific understanding and be prepared for discoveries that could fundamentally change our perception of life in the universe. The search continues, a universe of possibilities. The Fermi Paradox remains one of the most thought-provoking mysteries of our time. It asks a simple yet profound question. If the universe is so vast, teeming with countless stars and potentially habitable planets, why haven't we found any signs of extraterrestrial civilizations? It forces us to confront our place in the universe and the possibility that we might not be alone. This paradox challenges our understanding of life, intelligence, and the very nature of existence itself. The lack of definitive answers doesn't mean we should stop searching. Instead, it should inspire us to look deeper, to question more, and to expand our horizons. On the contrary, it highlights the importance of continued exploration, both of the cosmos and of our own understanding. Every mission, every experiment, brings us one step closer to unraveling the mysteries of the universe. We must keep searching, keep listening, and keep imagining. The quest for knowledge is a journey without end, driven by our innate curiosity and desire to understand the unknown. The universe is full of possibilities, and the answers, when we find them, will undoubtedly change our perspective forever. Each discovery, no matter how small, adds to the tapestry of our collective knowledge. The Fermi Paradox is a reminder that we are still at the very beginning of our journey to understand the universe and our place within it. It serves as a beacon, guiding us to look beyond our immediate surroundings and to ponder the infinite. The search for extraterrestrial life is ultimately a search for ourselves, a quest to answer the fundamental question, are we alone? This journey is not just about finding other life forms, but about understanding what it means to be human, to be part of this vast, interconnected cosmos.